We're halfway through, just about a little more. So a couple of comments. The test, yes, it's not an April Fool's joke, is on Friday, April 3rd. You've had 2 very detailed quizzes on the material. If you review those quizzes, your notes, and whatever homework you've done or not done, or try the chapter review tests or the review exercises, you should be in pretty good shape. Couple of comments on this quiz. I'd like you all to listen, please. When you use a model, whether it's a linear model or a quadratic model or whatever kind of model we're going to be learning in the class between now and the end of the year, and you use that model to find a result, like you take a year and you plug it in and it measures or whatever your dependent variable is, remember, the results from using a model is not the actual data. It's an estimate of what we think would have happened in that year, or a prediction if you're going outside. So when I asked you, for example, one of your intercepts, your y-intercepts look like this on one of the tests. I don't know which one it meant. And this represented 1980, and this represented 23.3% of, let's say, American females ages 25 to 29 who will never marry. Okay? When you interpret this, 2 things you got to keep in mind. All of this is important. I'm not talking about all females on the globe. I'm talking about a very specific part of the population. Females in the US, female ages 25 to 29, okay? Because we know, I hope we know that in other parts of the world, there's different standards of living. There's different cultural values about when people get married. So the chances of finding that 23.3% of every single woman in this age bracket, that's not true. So when you are describing and interpreting what a point means, don't say females, don't leave out the ages, don't leave out the nationality, describe it all. The other thing is, this is an estimated percentage. You don't state that in 1980, 23.3% of all American females ages 25 to 29 were not married. It's an estimate of that actual value. We don't know what that actual value is. That's what the model is doing. It's estimating for us. Okay? Yep.
So should we say like approximate?
Yeah, you could say approximately or estimated to be, yeah, just some kind of language. Okay? Look for hidden secrets. What does that mean? Well, on the second page of your individual quiz, I asked a question for you to give me 2 related real-world variables that had a positive trend. All you had to do is look at number 1. There they were. You could have just copied those down. And remember, when you describe variables, they describe a quantitative amount. So there should be some word that describes a quantity, and they should have units if you want full credit. But right here, often if you look back on quizzes and tests for either the true-false section or the give example of, there may be an example somewhere in your test. So that's just a little hint for Friday. Okay, preview exercises, get going. I've already used 5 minutes of your valuable time. So could, Ashlyn, could you read me number 1, please? What's another transformation that's going to happen to F? So horizontal shift to the right 1 unit. Perfect. And that's what this tells me right here. Horizontal shift to the right 1 unit. So what's going to happen to my X values? Are they going to increase or decrease? Increase. So I'm going to take all my X values and add 1. That's negative 218. This one would be negative 18. We're not done, but that's what you would do. And then what's the final one? Anybody? Vertical shift. Can you say that with more confidence?
A vertical shift down.
That's what I like to hear. All right. by 3 units. Okay, so what's that going to do to these y values here, 18, 8, and whatever I have? Right, I'm going to take those y values and subtract 3. Okay, so what I'd like you to do is continue this at your seats, and I'd like you to complete the next couple of questions. So, want to read this for us, James, number 1? Okay, before we answer that question, I want to show you that at the top of your preview exercises, a quadratic function was defined this way. A not equal to 0, okay? So notice you have two forms of a quadratic function. Just like with the equation of a linear function, you could say f of x equals ax plus b, you're used to calling am, or you could put it into like a slope form, point slope form. Okay, so you can have different forms of equations for functions. We called this one up, this purple one, the polynomial form, correct? This is called the standard form. This is what your book calls it. You will hear me also refer to this just because it's an old habit and it's how I learned it. And some books will call it the vertex form. They're synonymous, standard form and vertex form. It kind of makes sense that I'd call it the vertex form, right? Because you can see the vertex right in this form, just like you discovered back here. You could see in this form the vertex was 1 and -3. So you can look at it and tell, okay? So if we just have this general form, one other thing I want to point out, the a in your polynomial form is exactly the same a that's your factor, your common factor in front of x minus h quantity square, okay? So they're exactly the same. A never changes regardless of what form you're working with. So if I said in general, f is a transformation of my parent function x squared, and you're looking at this in general, how would you describe the different transformations that have gone on in generally in terms of h, k, and a? What could you tell me? What's happened to my parent function from looking at that? Any of the transformations at all. Doesn't matter where we start. A, the leading coefficient, that's what we call A, the leading coefficient represents, what did you say, Alan? A vertical stretch when A is what kind of number? Positive, greater than 1, yeah. When A is greater than 1, like 2, 3, 4, negative, 2.5, 5.5, whatever. An absolute value, let's put it that way, because it could be -2. It just looks, the parabola opens up differently. So the absolute value of A, let me put that in there. Let's see, absolute value of A is greater than 1. It's a stretch, okay? Or it represents a shrink, a vertical shrink, when what? Who wants to take on how we would write this part? When absolute value A is what? How do we know it's a vertical shrink? What boundaries do we have to put on A here? Between 0 and 1, right? It's a fraction. Whether it's positive or negative, we're saying when its absolute values between 0 and 1, we know it's vertically shrinking. All our y values are decreasing. That's by some ratio. Okay, so that takes care of A. What about H and K? What's happening with H and K? Anybody want to take one of those variables on? And tell me what it does to the original graph? Okay, so H, let's pick on H now. And Fabian says H represents a horizontal shift right by h units. Is that always true, regardless of h? It's only when h is what? Nope, because when it's negative, that becomes x plus h, right? Right, so when h is positive, that stays looking like x take away a 2 or x take away a 5, and we move to the right. So in the case where h is negative, that would be represented by this. X take away negative h, which is the same as x plus h. So how does that move my graph? Horizontal shift to the left, right? Because I'm inside the parentheses die, so that's moving things horizontally, okay? Horizontal shift left by h units. Whew, we're almost done. Now we got to talk about K. Who wants to take K on? Amber?
A vertical shift up or down.
Well, let's take it one at a time. Vertical shift. Where do you want to go?
Vertical shift
Up.
K unit by K unit.
K units if what?
If K is
Greater than 0. If it's positive, that plus stays positive, right? So we're going up. And Govani, you want to try the shift down? Good. Great. We've got all situations covered, except what if A, all right, we've got absolute value of A, but what if A is negative? What's going to happen? That's what we're doing down here. Does anybody know when A is a negative number? If we don't pay attention to, like, let's just say it's -1, so it's not stretching or shrinking. What happens to the parabola? Right, think about having a negative outside of f of x. It reflects it over the x-axis. So it's a sad, when you're negative, you're sad, you're very sad, and so your parabola opens downward. When you're positive, you're happy, and your parabola opens upward. Okay, you're a happy person, happy parabola. Okay, so when you look at this form, you can tell a lot when it's in this form. You can immediately identify the vertex, HK. By looking at the value of A, you know whether your parabola opens upward if it's happy or downward if it's sad, okay? You also know by the absolute value of A if it's a number bigger than 1, if it's going to be tall and narrow and stretch to the skies, or what happens if my value of A gets shrunk. It's getting wider, wider, wider. And what happens as that value of A gets closer and closer to 0? I can't be 0 because then I wouldn't be a parabola. But, oh, what am I getting close to being? Infinitesimally as I get closer. And here's the x-axis right here. So as I get, A gets smaller and smaller. Yeah, slightly curved. And what am I approaching? I'm approaching a linear function, right? I would look just like, in this case, I would look like a straight horizontal line, right? So that was the thought question. All right. So, but you just loved my little demo, didn't you? Okay. See, all teachers are frustrated actors and actresses, right? Not really. Okay. So the big question of the hour, students often ask is, how do I move from one form to the other? In fact, one of my students asked before we even get to number 2, when we were back here, oops, she said to me, Linda, this is cool. When I have this form, I can tell the vertex, but how do I tell the vertex when it's in the other form? So for example, let's just do a little side thing here. What was the equation we started with in the preview exercise? 2 times x minus 1 square minus 3, right? So this is in standard form. And if I want to put this in polynomial form, the only thing I can do right now, the only thing I can steal is that this value of A is the same. So when I go to my polynomial form, I can do this, 2x squared. That's the only thing I can do right now. I can't look at the standard form or the vertex form and figure out as I'm looking at it what B and C is. So how do I get, well, then someone in my other class said, but I can tell what the constant term is. I said, you can? She said, well, not from looking at it, but by plugging x equals 0 into my function. That's where my y-intercept is located, is when x is 0. So a student in my first class said, well, f of 0 gives me 2 times 0 minus 1 quantity squared minus 3, which gives me 2 times 1 minus 3, which gives me what? 2 minus 3, negative 1. Look at the points we did. Is 0, negative 1 the y vertex on your graph? Yeah. So then I know this so far. I know that much. Well, how do I find b? Unfortunately, well, there is a way to find, well, to find b or to go from this form to the standard form, you just have to do your algebra route. So you square this binomial, x minus 1, and you get x squared minus 2x plus 1. Take away 3, then you use your distributive property, 2x squared minus 4x plus 2 minus 3, and that gives you 2x squared minus 4x minus 1. So now you know what b is. B is negative 4x. Okay, so you could figure out a and c, but you've got to do the algebra route to get the value of b. Okay? So that's how you can move into that form. However, to find the vertex from the polynomial form, all we have to do is use this formula, which some of you may have seen in Math 096 if you took it. So let's go back to that equation we just came up with, 2x squared minus 4x minus 1. We know the vertex from graphing that's located at 1, negative 3. That's what we started out with. But if we got it in this form and we had to figure out where the vertex was, all we do is we use this formula. H, which is our vertex, we used to call it the x value for our vertex, but now we call it H, is the opposite of b over 2a. So as long as your original quadratic function is in polynomial form, you can identify what a and b are when it's in polynomial form. So this is 4 over 4, which is 1. So now I'm halfway through. I've got 1/2 of my vertex coordinates. How the heck am I going to find out what the y value is when x is 1? What do I do? This tells me take the x value of your vertex and plug it back into your function. That's how we always find y. We plug in an x and out pops a y. Here we're talking in functional notation, so we plug in this value, negative b over 2a, which is 1, back into the function. I plug it back in to get my y value. So I get 2 times 1 squared minus 4 times 1 minus 1. That's 2 take away 4 is negative 2, take away 1 is negative 3. Voila, it matches what we found in our original preview exercises. Okay, so anytime you're asked in an application problem, to maximize something or to minimize something, whether it's maximum area, minimum cost, maximum profit, okay? You have to find the vertex. And the answer for the maximum is always going to be the output, your dependent coordinate of your vertex. That's what we're always looking for. All right, so let's do some graphing, and then I'm going to set you loose here on your own to do some work. So what form is this particular quadratic function? What form is this? Polynomial, so we're in the polynomial form. All right. And so if I now want to put this in standard form, I want to take this polynomial, f of x equals negative 1 times x squared plus 4x plus 1, and I want to put it into an equivalent form that looks called the standard form or the vertex form that looks like this. Okay. Is there anything I can do a direct transference from one form to the other right now? Anything I can do right now without even thinking? Anything? Ashlyn, is there any piece of this function right here that I can look at and put right over here? The a, right. So a is what in this first -1. So over here, it's going to be a -1 as well. So I've got a start. I can feel proud of myself that I can look at one of those forms, but I can't look at this right now and know what my vertex is. All I know is that my parabola is going to be sad. It's going to open downward, and my vertex will be a maximum point. Okay, that's all I know. So I could have asked the question, what is the maximum of the parabola, right? What are the coordinates of the maximum? It's going to find the same thing. All right, so how am I going to find h and k? Well, h is the opposite of b over 2a. So all I have to do is look at my polynomial form, identify a and b, and plug away. And this is so cool because you can do it very quickly. So my value for my vertex, the x value of my vertex, which we call h, is going to be located at 1. Did I screw up?
Yeah, it's 2.
Oh, a is -1. Oh, good, thank you. In the back of my mind, I'm saying, I know that's not the answer I got in the first class, but I just move along so quickly, I really rely on you to catch me. All right, so that's 2. All right, now to find my y value for my vertex or my k value, I just plug that right back into my function. I find f of -2, which is -1 times positive 2, times 2 squared plus 4 times 2 plus 1. So that gives me -1 times 2 squared is -4 plus 8 plus 1. That gives me 5. So I go to the right 2 and I go up 5. And there's my vertex. I know it's the king of the mountain or the queen of the mountain. There's never going to be a y value or an output value higher than 5. So the maximum value of this function, listen to this, the maximum value is 5. Whenever you're asked about the most something can be, you're not interested in the x, you're just really interested in what's the top value here. It's 5. You are interested in the x to a certain point, okay? You want to know where it's located for your independent variable. But when they ask the question, what's the maximum, you say 5. And that helps you with the range, because the range is going to, the highest value in your range is going to be 5. So your range, even though this isn't on there, your range is going to look like this. It's going to have 5 with a bracket, and then we know all the other values are less than that, it goes towards -infinity. All right, so we now have 2, 5. Write the quadratic function in standard form. I'll be the writer. You want to tell me what to write? One person at a time. Dean, where do I start writing this in? Just tell me what to write. If you want to pass, say pass. Okay. Fabian?
Negative x minus 2 squared.
Negative x what?
Wait, sorry. You have to put dx minus 2 squared.
I didn't hear what you said. I'm sorry. I want it in standard
Yeah,
form.
negative.
Then open parentheses.
Yeah, open parentheses.
Yeah.
X minus 2
Right, because that's h, goes right there,
squared.
Yep.
Plus 1.
plus 5. Okay. Now, what's the only, well, not the only mistake, what's the tendency for students when they're writing these on quizzes and tests? This won't be on your test, this is next time. They forget to put the square on. They forget to put the 2 there. They get everything filled in, but if you left it like that, it's a straight line. So don't forget the 2. That comes along. That comes along for free, the 2, right? You don't even have to figure that out. We already know this opens downward because a is negative. And let's find the y-intercept. To find the y-intercept, x equals 0. So we find the value of the function when x is 0, so we just plug it back in. and we get -4 plus 5 is 1. So 0, 1 is my y-intercept, and I come right here, 0, 1, 2, 5. I automatically now know another point on that parabola. Can anybody tell me what the other point is that I automatically know just from these two things that I just plotted? Someone other than Fabian and Amber. What other point can I get automatically? 0, 0. No, it's 0, 1. It's all right. What other point do you know, knowing the characteristics of a parabola, James? Right. Remember, the line x equals 2, the straight line that goes right down through your vertex, the x value of your vertex, x equals 2 is your line of symmetry. So James says it reflects. So if I've gone 2 steps to my left from 2 to 0 and I'm 1 step high, what's the coordinates of the point to the right of my line of symmetry? You go 2 steps to the right, you're at 4, and you're at exactly the same height. So you can always find your point of symmetry. You only really have to draw 1/2 of a parabola, and then you can just throw a few points in on the other side of the line of symmetry, regardless of what side you're on. X-intercepts. How do you find x-intercepts? X-intercepts. What's true about any x-intercept? Y equals 0. So what do we call y when we're working in function notation? F of x equals 0. So here's f of x. It's -1 times x minus 2 quantity squared plus 5. Or in the other form, in polynomial form, it was -1x squared plus 4x plus 1. So you set f of x equal to 0, whether you have it in your standard form or your polynomial form. You now know how to solve quadratic equations. Okay? So this is the form you're more familiar with. When it's in this form, in your polynomial form, you can directly go to your quadratic formula. A is -1, B is 4, C is 1. So let's do that. X equals, you're solving for the values of x. I don't want to see any quadratic formula without an x equals, at least at the beginning. X equals the opposite of b plus or minus the square root of b squared, which is 16, plus 4 over -2, which is -4 plus or minus the square root of 20 over -2. -4 over -2 is the same as 4 over 2. So I can just call this 4 plus or minus the square root of 20 over 2. Square root of 20 can be simplified. Square root of 4, square root of 5, which is 2 square roots of 5. So that's 4 plus or minus 2 square roots of 5 over 2. I have 2 as a common factor all the way around. So this is 2 plus or minus the square root of 5. So my x-intercepts are 2 plus the square root of 5, 0, and 2 minus the square root of 5, 0. Those are the exact values. These are the exact solutions for this equation. Don't give me a decimal value. If you want to graph that, you go to your decimal value. This is something like approximately -0.23, and this is approximately 4.2. You can use those approximations to come up here on your graph and put in your x and your y, your 2x intercepts, and then you're done. Just put arrows on your parabola and you're all done. If it's in this form, you don't have to multiply it all out. You know how to do it. Oops, it's not +5 up there, is it? What is it? When I did this. No. You guys didn't even catch me. What are we doing here? The parabola. Did we do that correctly? Okay. All right. All right. All right. All right. You're right. We did it right. Okay, good. So what do I do here to solve this? How would I solve it in this form without squaring it and putting it back in a polynomial form? You learned how to solve quadratic equations of this form, where you have a perfect square on one side. What would be my first step here? Subtract 5 from both sides. Now what? Divide by -1. Now what? Yeah, what do I, no, I don't want to square root. So what do I get when I take the square root of both sides? Cancels that square root. I agree with that, die. And what do I get on the other side? Nope. 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 Plus or minus the square root of 5, right? So x equals, bring the 2 on the other side, 2 plus or minus the square root of 5. Same exact answer we got there. Okay. You have 2 x-intercepts, folks. You should be looking for 2 values here. Do something in your head. Do something. Make some kind of visual for yourself, because you always forget the negative square root. Try to hold a visual up there, because like I say, I've done song and dances for you and it hasn't mattered. Okay? Just remember, think of what you're finding. Have a visual idea of what you're doing. When you find a solution to this equation, you are finding the 2, in this particular case, the 2 places on your x-axis where this parabola crosses the x-axis. Notice your parabola goes from being a positive value to a negative, right at those points. On one side of the parabola, you're happy, positive y, and the other side, you're negative. How would you change the function back? We already did that. And the final thing I want to do for you, I'm going to do it relatively quickly because I want you to spend some time working on your own, is how do we go backwards? Let's see if we can do this together with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 very smart people trying to figure this out. Let's find the equation for this quadratic function. We want it in both forms. We want it in standard form, which looks like this, and we want it in polynomial form, which looks like this. Can anybody help us out, get us going? Amber's going to say something, and then she's turned off.
H is going to be 3.
H is going to be 3. And she got that right here from the vertex. So Amber's turned off. I'm the bartender. I get to say who can keep going or not going at all. She's turned off for the rest of the day. Any other piece of information we can get? Kira? K is 5, right. That's the y coordinate of your vertex. Okay. What do we have left here? A. We have to find A. Do we know anything at all about A? Anything? It's positive. That's all we know. So Dean says, and Kara says, Dean and Kara says A is positive. And how do you know that? Parabola is opening upward. It's a happy parabola, right? Okay. All right. We still have to find the value of A. And we need some information because we have kind of some things in that equation we don't know. We can't solve that equation right now for A because we don't know what X is and we don't know what Y is. What do you do when you have a line and you're trying to find B and you know the slope? What do you do to find B? That's the last thing we have to do here after we plug in the point 0.023 to solve for A, the last 2 steps. Solve this for A, please. What do I do? 9A plus 5 equals 23. Yeah, Ashlyn? Move the 5. How do I move the 5? Subtract it, okay. And then what? 2. Now I have everything I need. F of x equals 2 times x minus 3 quantity squared plus 5. I'm not going to put it in the other form. You all know how to do that. Start your class activities. Use your flags if you need any help, folks.